That just means it's recording. All right, so we are doing 2-6 and 2-7 combined. 2-7 by itself would be maybe 4 or 5 questions in a homework assignment. So I'm not, and they're about the same stuff. So we don't really need to worry about doing that on its own. So.
We need students with the last name U, C, W, X, Y, and Z. Go to either tower A or D for your pictures. Go to the tower that's closest to your classroom. Thank you.
Okay, for our transformations of graphs today, we can transform lots of different functions. We can transform just a linear function and move it all around. We can do a quadratic, which is your U shape, and move that all around, absolute value, square root, all different things. But the ones that you're going to actually have to move, we're going to move x squared, and we're also going to do absolute value. We're going to do absolute value the most, though. So these are the pictures and the points of the graphs that we're going to be shifting around, just so you'll have an idea of what they look like. This is f of x equals x squared. It has a vertex on 0, 0. Our first set of points are 1, 1, and negative 1, 1. And you get those by plugging in the x values into this function. 1 squared is 1. Negative 1 squared is also 1. Okay. Our second set of points we get by plugging in 2 and negative 2. What is 2 squared? 4. So when I'm at 2 on the x value, my y value needs to be 4 because this graph is squaring all the x values. Then negative 2 squared is also 4. And when we connect them, we make a U shape. The second graph that we'll be moving around is the absolute value of x. So we're going to do a similar thing. We're going to start with 0, and then we'll do 1 and negative 1 and negative 2 and 2. What is the absolute value of 0? 0. So if I was at 0, the absolute value of 0 is 0. What about 1? What's the absolute value of 1? 1. Okay. What's the absolute value of negative 1? 1. So at negative 1, we're at 1. What's the absolute value of 2? 2. And what's the absolute value of negative 2? Also 2. This is a stray mark. I need to move that little tiny purple point. Go away. Nope. Guess I can't. Erase it. Okay. So this one is a V shape rather than a U shape. So to get your absolute value, once you know your vertex, to get your other points, our slope is 1, isn't it? Up 1, over 1, up 1, over 1 for our absolute value. And then you go the other way, go backwards, up 1, back 1, up 1, back 1 to get your V shape. So absolute value gives you a V. X squared is going to give you a U shape. Okay. So once you know where your vertex is going to go, it's going to be really easy for you to draw the rest of it. So what we're going to do is we're going to take these two shapes, this U and this V, and we're going to shift them around. So we're going to move them left, we're going to move them right, we're going to move them up, we're going to move them down, we're going to flip them over, we're going to stretch them vertically, compress them vertically, so change their slopes a little bit for those, and that's what this section is all about. So we just need to know where the numbers go to move things in which way. All right. So our first kind of translation, so we'll do translations first, which is shifting up and down or shifting left and right. We're not changing the size of anything. So we'll start out, we'll do vertical translation. So this just means you're moving things either up or down. So to move something up or down, what we're going to do is we add a number to the very end of our function. So whatever function we had, if we want to move something up, we'll just put plus whatever we're going up. If we want to move it down, we just put minus whatever, however many units we want to use it to move it downward. But it's going to be at the end of the function. So technically, you would say f of x plus k to move something up, or f of x minus k to move something down. But this number is not inside any parentheses or inside any operation. It's just added at the very end. So if you just add it at the very end, that's an up or downward shift. Okay. So we'll look at two examples of what this would look like in an actual function. So I have the absolute value of x minus 3. That minus 3 is not inside my bars. It's not inside any parentheses. It's on the outside. So that's taking my V shape and it's moving it, is it moving it up or down? Down, and down how many units? 3. So what I would do, if I'm drawing this graph, I would go down 3 units, 1, 2, 3. So this was down 3. And then from here, I'm just going to draw that V that I drew up above. So as long as I know the slopes of my sides, I can do it. So remember, to get from one point to the next, I'll go back down a second. You go up 1 over 1, up 1 over 1 the other way, and then draw your straight lines for your absolute value graphs. So here we go. Up 1 over 1, up 1 over 1 the other way. And since these are straight lines, we don't even need our second set of points. And we just draw our lines. Same thing with the x squared. If you have a number at the end, that would shift it up or shift it down depending on if it's a plus or a minus. Okay, the next kind will be our horizontal translation, where we're going left or right. For the up and down, the number is outside of the parentheses or outside of the operation, whether it's square root or cube or whatever you've got going on. But for horizontal, it's inside of your parentheses or inside of your operation. So we could do f of x minus h, f of x plus h. So you're going to see actual parentheses or inside your absolute value. That's where the number is going to be for it to be moving left and right. Okay, so inside is left and right, outside of the operation is up and down. What's kind of weird with these If you said x minus something, which way do you think it would move, left or right? We would think left, right? Because negative numbers are to the left, but it's always opposite when you're doing left and right. So you have to remember this. So this is a very important. If you have a minus, this is supposed to be an asterisk, sorry. If you have a minus, you are going to the right. Minus means we go to the right. A plus means we're going to the left. Okay, so let's try an example here. Let's go with f of x is equal to the absolute value of x minus 4. So since it's inside of our bars or inside of our operation, we know inside is left and right. Okay. And minus tells us that we're going which way? To the left or to the, how do you do right in sign language? R. Is this R in sign language? Yeah. So that's R and that's L. So are we going left or right? We're going to the right. Okay. So we're shifting this absolute value graph right 4 units. So I go 1, 2, 3, 4. That's where my vertex is. What kind of shape am I going to draw since it's absolute value? We're going to draw a V shape, right, for absolute value. If I had done a square, that's when we do the U, but this is an absolute value. So same thing that we did before to get our second set of points, up 1 over 1, up 1 over 1 the other way from the vertex. Okay. We'll do a combo. This will be fun. So you can shift left, right, up, down, a bunch of combinations of things. So I want you guys to try and do this one. So just say what the shift is and see if you can do it. And then we'll check it. We'll do another absolute value one because I like these graphs better. So absolute value of x plus 2 and then plus 3. So go ahead, write down what your transformations are and see if you can figure out how to sketch that. Ashley, Jackson, Quinte, and Macario, I need you to type something in the chat. Okay, just making sure you didn't disappear. When you think you got your picture, look straight into the camera. Some of y'all are doing a great job on those death stares. All right, so the inside part, those are our left and right, okay? So we have x plus 2. Plus means we go which way? Left or right? To the left. Yeah, so this is going to go left 2. And then the plus 3, there's no sign changing or anything funny, so this means we're going up 3 units, right? Okay. So for us to start our vertex, we have to go left 2 and up 3. So that is our starting point. Did everybody get the starting point of left 2 and up 3? So we shifted left 2, up 3. Okay. Now we're ready to draw our V. So we're going to use the same thing that we did before. Up 1 over 1, up 1 over 1 the other way. Okay. The first one right here. So we went left 2 because it was a plus. Inside is left or right, and a plus means go to the left. It's like backwards from what you think, so you have to think, oh, got to switch it. Got to switch it when you go left and right. So I went left 2, up 3, and put my point. Now we'll talk about reflections. So sometimes they can be flipped upside down. What do you think is going to be in the equation if we want something to be flipped upside down? What do you think we're going to have? Yeah, some negatives, and it just depends on where the negative is, will tell us which axis it flips it over, okay? So if you are going to go over the x-axis, your negative is going to be on the outside of your graph, or of your function. So if our negative's on the outside of the parentheses, that's going to go over the x-axis. If we're going to flip it over the y-axis, so take it like this and flip it over the y, our negative is on the inside. Most of the time, I'm just going to have you draw ones that go over the x-axis that are just a reflection upside down. But occasionally, you might see some problems where the negative is on the inside. That just means it's a flip this way rather than flipping down. So it flips over. Okay. So we'll look at, we'll just do the absolute value. I kind of like these kind. So if I have f of x equals negative absolute value of x, did I do any shifting left and right or up and down? Are there any numbers inside the absolute value or on the outside? No, so that means I haven't moved like where my vertex is, but instead of being a right side up V, now it's going to be, how do you do upside down with your hands? Upside down V, can anybody do that? Do you have to stand up to do it? Like this, that looks weird. I haven't twisted my arms. So our V is going to be upside down rather than right side up. So that's what a negative in the front does. It flips it over the x-axis. Our vertex is still on the origin. We don't go up 1 over 1. Now we're going down 1 over 1. Or over 1, down 1. Either way, you want to think about it. If your negative is on the inside of any operation, that's going over the y-axis instead. But I won't have you graph any of those. Any questions on reflections? If there's a negative in front, it means we are upside down. Same thing with a quadratic with a U. Upside down would be a reflection, a negative in the very front. Our very last thing, so we've moved it around, we've flipped it over, but now we're going to change how steep it is, what our slope is, or what we call a vertical stretch or a vertical compression. And stretch, sometimes they use the word expand. It could be a vertical expansion or a vertical compression. Okay, so the next thing, these are our vertical expansions or compressions interchangeably with stretch. And these are really fun to do. Not fun, I mean, I think they're fun to do with the absolute value. They're not quite as straightforward with your quadratic, but we'll get there in the next chapter. But I do want you to know how to graph them with the absolute value. So the way this shows up, so we've added numbers inside of the absolute value or the parentheses. We've added numbers at the end. We've put a negative in the front. We've put a negative on the inside, but we haven't multiplied by anything. So if you have a number that is multiplied, that's going to show up as a stretch or compression. It's going to make it either taller or it's going to make it skinnier, a little squattier than what you had before. Okay. So the way this shows up as a number multiplied in front of your function. So we've got two different things that could happen. It could be stretching it or expanding it, or it could be compressing it. So we need to know which numbers are going to make it bigger, which numbers are going to make it squattier. Okay? So if you're thinking about something and you have a V shape or any shape like that, if you multiplied all of your Y values by 2, if I multiplied them all by 2, I'm going to get a little bit more narrow, but it's stretching it vertically. So if I double all my Y values, it's going to stretch it vertically. Okay? What kind of numbers would make it condense, would make it smaller? Would make my V shape to where it was a little bit more, a little flatter. So I said doubling it makes it look like this. What's the opposite of doubling something? What's the opposite of double? Yeah, divide by 2, right? Doubling something or halving something, like to cut in halves. So if I cut my Y values in half, aren't they going to be shorter? They're going to be shorter and it's going to be squattier. Okay. So if the A value or whatever I'm multiplying by is bigger than 1, it's going to increase the numbers. So if A is greater than 1, you're going to have a stretch or an expansion. Like if you multiplied it by 2, it's going to get taller. If you multiplied it by 3, it's going to get taller. But if I multiplied it by a half, it's going to get cut in half. Or a third, it's going to get cut in a third. Or a fourth, it's going to get cut in a fourth. So anything between 0 and 1 is going to be a compression. So bigger than 1, stretch or expand. You might want to write that if your inequalities aren't that great. This means more than 1. A compression are numbers in between 0 and 1. So we'll look at one of them that's a stretch and one that's a compression, both with absolute value, so you can be familiar with that. So on our first one, we have 3 times the absolute value of x. Is this going to be a stretch or a compression? Is it going to stretch or compress? It's going to stretch because 3 is bigger than 1, right? So we can write a vertical stretch of 3. And now I'll show you how to graph it. This is changing the slope. Carrington. She fell asleep. All right, this is changing the slope in our V's. We are going to, instead of having a slope of 1, we're now going to have a slope of 3. So instead of going up 1 over 1, we're going to go up 3 over 1 for these problems. So this stretch of 3, this is our new slope when you do absolute value graphs. Did we shift left, right, up, down at all? No, so we still start at the vertex. Normally it's over 1, up 1, but in this case, we have a new slope. And our new slope tells us that we go up 3 over 1 in both directions. Remember, we can write it as a fraction. Okay. All right, do we have a stretch or compression on this second one? It's going to be a vertical compression, so it's going to be a little bit wider, a little bit squattier than it was before. So this one is a vertical compression. That is a half. You might also see it's been set as a vertical compression by a factor of 2, because you compressed it to a half, so they were saying you're cutting it into 2s. So they might not use the number 1/2, they might use the number 2 for that part. Did we do any moving? Nope, we didn't do any moving. So our vertex is going to be the same. What is our slope? Up 1 over 2, up 1 over 2. Do we see how that has been compressed from the normal V shape? Kind of like if you get a trash compactor and push it down a little bit by a half from what the normal V was, now it's a little bit more compressed that way. The first one we went and stretched it vertically, it got taller. The second one, it compressed it vertically from there, okay? So we're gonna do one that's got a whole bunch of stuff, a super duper combo, and then you guys can start working. So we have 2 times x plus 4 minus 2. So I like to go all the way across and just write down what all's happening before I start to graph it. What is a 2 in the front? What is this going to be? It's going to be a vertical stretch of 2, which will be our new slope when we actually draw the second set of points. Which way are we moving? Because it's on the inside. Left 4. Remember, plus means left. And on the outside, is this up or down? And down 2. So I go left 4, down 2, where I'm starting. Normally it would be up 1 over 1, but instead I'm going up 2 over 1 because my slope was 2. Are there any questions on this so far? Inside, left and right, outside, up and down, a negative flips it over if it's in the front, a number multiplied in the front and tells you vertical stretch or vertical compression. Okay. All right, I want everybody right now to go ahead and get on to your CUDA. You do not have to write anything down on a piece of paper for this assignment. Okay. I will reassign it to you if you're under 80%. This one should be no lower than 80% for these problems so that you can make sure that you get it. Or if you finish it in like less than 3 minutes, then I will for sure reassign it to you. So everybody needs to be logged on. I'm going to go ahead and check that right now.